You can say height, okay, height, weight, somewhat like this, right? So, but coming to the data, this big data, in order to define this big data, there are, we call a mantra, 5V mantra. It's called 5Vs. So by these 5Vs, we can know, is the data big or not? The 5 is simple, these 5Vs. If data is having any one V, then it is considered as a big data. Otherwise, it's not a big data, right? So we'll see all the what are the 5Vs and why they are called big data if they're having any one V for the data, right? So yes, coming to the, yeah, before going to know about the big data, let me take some motivation kind of thing. See, take information. See, nowadays, the very important thing is that nowadays, storing a data is cheap. Storing a data is very, very cheap nowadays. Suppose if you'll see 5 years ago, or not 10 years ago, 5 years ago, and so on. So let me take any hard disk. So you might be seeing the computers in the old computers in your homes. Some of you might be seeing old computers or laptops. So there you can see the hard disk size. So there, even if the hard disk size, it may be of computers or laptops, the hard disk size is around like a 500 MB kind of thing, in MBs only, not even GBs. So you can, if you want to purchase the hard disk, so obviously it will took around 10,000 or 15,000 kind of things. But nowadays, if you want to buy hard disk of 1 TB, can anybody say what would be the cost of 1 TB hard disk nowadays? Anybody?
It's around 1,500 something.
Yeah, 500,000, even around thousands only, right? Around less than 3,000, less than or equal to 3,000. So it's like, yeah, of course, thing is, so you might observe like, so what I want to portray is that like storing a data is very, very cheap nowadays. Even not only a physical devices, if you'll go and advance some kind of things, so there you have a clouds, right? Even clouds comes into a picture, not even going to physical storages, clouds are coming into the pictures. So there some companies are like offering to store a huge amount of data. So if you want, suppose if you start a company, not only a company, if you want to store some data, even simple Gmail, you can see the Gmail. Can anybody say how much of space is provided by the Gmail freely? Can anybody? Gmail account.
15 GB.
15 GB. Yes.
15 GB.
Earlier, in like 5 years ago or somewhat kind of thing, 15 GB is a pen drive, right? So pen drive is having 15 GB. That makes around 800 rupees or 1,000 rupees around. Understood now? But nowadays, even Gmail for per account, you will get a 15 GB of space freely. That's how cheap is storage or storing an information, storing a data. That's what so here, if you understood, so because of that reason, that is a basic reason, you might observe these things, storing things. So because of the thing, so everywhere data is huge and increasing, and nobody no need to lose the data. Anybody no need to lose the data. So they can store the data of historical data, like mining a data. So GBs of data, TBs of data, trillions of data. So that's what data is increasing everywhere. That's the truth and fact. Data is increasing everywhere. You can see a simple calculation here. Simple calculation you can observe. Exabytes data of day per day. Exabyte of data. So if data storing is cheap, that is a good, but the like a consequence of storing a data cheap is handling or processing the data. How to handle this data and how to process this data and what should we do with the data? That's the question here. So data is useful. Nobody wants to lose the data, right? So why? So there is a big challenge behind storing a data, that is handling the data as well as processing the data. Understood? So that's what main observation on the big data. So here you can understand some reasons why the big data is arised. This is what are some reasons. So you can understand like customer's perspective, suppose business perspective. If you start any business, if you want to start any new business, even any startup kind of thing, if you want to observe any other businesses, you can take the historical data of that business as well. Or if any business wants to grow, or like if you want any ups and downs comes into the business, or if you want to change the dimensions of the business, or if you want to change the any pattern of the business, then also you should look into the business data. For example, not only business side, medical side also, this big data is like expanding in such a way. So coming to the medical side, suppose even for an example, if you go and visit a doctor, so what you will ask, suppose if any a person got a diabetics, so what is the first thing doctor will ask? So is anybody in our family has this diabetics or not? So historical data about the family. You understood? So there is a necessity of the data for anything. There's a necessity, huge necessity of the data. So why? So here you can see using the data, here you can understand, right? Using the data, understand customers and business operations. That's what we've been discussing. Understood? So yeah. So this is a data. If you'll observe this data, you may not the very main interesting thing about the data is that this data is different forms. This data is different forms, not only a text format. Don't think a text format. Data is not only a text format. It is also a form of images. It's also a form of audio. It is also a form of video. It is also a form of different table structures. So why the data sometimes is said to be simple way, the data basically categorized as this thing. Can you observe here? Structured and unstructured data. Structured and unstructured data. So these are one type of the data by where we can have a clarity about the data type, and so that you can go for the storage type, as well as you can go for the handling methods, handling technologies of that kind of data. That's what we need to understand about the data first. Okay, right? So you can see here, these are the different companies you might be seeing on the screen. So these are the different companies of the data. See, I told you data is different forms, right? So you can see YouTube, the very well-known thing, right? So YouTube has a data in the form of, mainly in the form of, can anybody say what is the kind of data here? The form of videos, exactly. So YouTube in the form of videos, and Twitter in the form of tweets. And again, these tweets may be in the form of not only a text tweets, they could be a small bit of video, as well as the images, as well as audios. Understood? So this kind of video, audio kind of data. So Twitter, this is what are twisted. So around 4.5K, you can see 4.5K. Understood? Post they'll get. Similarly, you can see Skype, Instagram, Uber, Google Contacts, Wikipedia, Amazon. Understood? Tumblr, this is also an application. Understood? So these are very a good picture to understand. You understood? So 4 lakh, simple example I'm going to give you, 4.14, sorry 414K, you can see per minute. It's per minute. You can simply you can estimate for per an hour, similarly per day, per month, per year. Understood? This is what a huge data. Yeah, this is also same picture. So it's a small difference. And yeah, So these are the, see, we can say for a like media. So these are the kind of sources of getting a big data. These are the sources, right? So yeah, I told you, you may ask, I told you like, so sir, how you call like this is a big data? I told you 5 V's, right? It's a 5V mantra called for the big data, 5 V's. The very first V is volume, right? Volume, then nothing but a size of the disk. So if the size of the data is high, then it's a big data. Similarly, variety, I told you, right? Variety, not only a size. So you might be thinking about, whenever we say the term big data, you might be thinking about only the volume. No, even the size of the data is small. Remember this, a very good, very important thing about the big data. Many people thinks about that volume. No, not only a volume. Even the size of the data is less, but if it is having other features, kind of variety, if the data is having a variety in nature, even the size is less, then it's called as a big data. Variety, I told you, no, variety nothing but some data is having images, some data is having videos, some data is having audios. Understood? Some data is having text, who knows? So there's a variety of data. There's a variety. So it is also called, if the data is having a complex data, then it is also a big data. Even the size is
Hello,
less.
sir.
Yes. Sorry.
Sir, I have one doubt, sir.
Yes. Please tell me.
Sir, video, audio, video and pictures are set of pixels only, no, sir.
Sorry, your voice is
Both
not.
are same, no, sir.
No.
Sir,
See, now.
pictures and
Yeah, tell me.
pictures and videos are a set of pixels only, no, sir.
There is change in pixels, right?
There is no
How can you?
matter.
No. How can you?
No different matter.
Sorry.
No difference, no, sir.
Difference of what you, in terms of what? Suppose if you want to store an
Set
audio.
of
No.
pixels
Tell me.
means
No. Tell me. So you're talking about that visualization. Okay. Now I'm asking about storing. How could you store a video file? How could you store an audio file? How could you process the audio file? How could you process the video file? In terms of not a creating. See, creating an audio file, creating a video file is different. Storing an audio file and storing a video file, and processing audio file and processing a video file. That's what I'm talking. Understood? So, okay. So that's what a variety of data. Next one, velocity. Yes, just now we have seen, right? In YouTube, in tweets, in Instagrams, a velocity nothing but how much of data is getting into dump into that source per second or per hour or per day. Understood? So that's what a velocity. That is a velocity. So coming to, so these are the fundamental basic 3 V's, but later two fellows, IBM as well as SAS, the two added to 2 V's, they are called veracity and variability. Understood? So what is meant by veracity? Anybody?
Speed of accumulation of a data.
Yes, exactly. Yes, right. One more, any one more like any one more meaning? Any one more meaning, another meaning?
how fast transmission will be done.
Okay. See, yes. See, veracity, yes, of course, speed and as well as, see, veracity has different characteristics. Veracity of data is having different characteristics. For example, accuracy and as well as a quality, as well as abnormality. Understood? As well as like, see, if you take a data, if the data is having a sequence, if the data is having a sequence, particular sequence, So for example, if you take a temperature data, so it has for particular gap with the time. See, for example, x-axis time and y-axis or x-axis temperature, anything, anyway, no problem. So if x-axis increases, y-axis also increases, like temperature at time, with time temperature increases, with some particular time temperature decreases. Understood? Is a curve of the temperature with respect to time. So suppose if you'll if a temperature records are missed for this duration, for example, for this duration, if the temperature is not available for particular for some time, there is inconsistency in the data. Understood? So there is abnormality in the data. We can say some data is missing, some portion of data is missing. So it has a pattern, but because of that missing data, we can't give some accuracy about the data. So that's what when we determine the characteristics of the data. So there, if you find some abnormality or defect in the data or noise in the data, it may be called as also noise, so or inconsistency. It's a kind of things, right? So if the data is having any of these features, so we can say this one as a veracity. That's what a veracity of the data. Understood? So these are like proposed by this IBM. So Love, so they're adding this one more V about the data. So the data is having different features. So that's what I'm discussing you. So if you want to classify them as a big data, so if you got any defect about the data, or if you got any characteristics of the data, then we can call this one as a big data. So last one is variability. So simple, the very simple thing. So variability, nothing but spreading. So when you take the analytics, the statistics, we'll use the stats to analyze the data. There you can calculate this spreadness, right? The amount of spreadness, kind of things, right?
Standard deviation.
Yes, exactly. SD as IQR, like interquartile range, as well as variances, right? So these are the terms coming to the stats of the data. So this is what variability is, nothing but a rate of dispersion. So if it is how much it is spreads, this data is around. So that's what respect to any parameter, if you take a data is spread a wide range, then it is also called as a big data. Understood? So in this way, these are the 5 V's. These are the 5 fundamental V's. Yeah, here I given some things. So examples also. So these are the 5 V's. So that we can understand about the big data. Understood? See, 1 minute, I'm getting. Understood? So these are the 5 V's. So if any V matches to the data, we can call them as a big data. So if the big data is used, so these one sentence I would like to bring in with you. So these are Davenport, like he is an author, like he wrote many books. In the books also, he quote about the big data. If you can read this one and understand this thing, really helps you to understand the things. So extensive use of data, statistical and quantitative analysis, explanatory and predictive models, fact-based management to drive decisions and actions. You understood? See, there is a huge data, not only in terms of volume, but also other views also. Remember that, keep in mind. So this use of data is by either quantitatively, you can analyze the data, or statistically, you can analyze the data. And also you can propose some methods, or you can use some already proposed methods or already derived methods to explain or like to predict the nature of the model. Understood? Somebody can mute this. Somebody can mute yourself. Yes, thank you. You understood? So these what are like these are the things. So if you want to use the data and use some analysis as well as use some models, so they will be should drive you. So why you are using some methods and why you're using some analysis on top of data? The main thing is like to make some decisions. Remember this, to make some decisions and to make some actions. Understood? So these decisions may be for future or present, but some decisions you could trust the data or you could trust your analysis, you could trust your methods to take some decision as well as some actions. For example, take a share market. I think many of you know the share markets, right? So in the share markets, even they will use some methods. How could you show, how could you know that some, for example, any Tata is there, so Tata Motors, you can know some kind of companies and BSE or NSE exchanges. So there you can know any stock market price. So one company is getting lose on a day, or some other day the same company is trying to build up his stocks. So who knows that? Because so the things, so the one who is like investing in the market, stock market, so they have some analysis and they need some models to analyze the things. So even the entire thing is carried by the data itself only. They're having a historical data, and they're having some kind of analysis on the top of this data. So these are the things, right? So the very so Davenport, he gave some things on this data. So this is what a statement is quoted from his book Enterprise Analytics, and is also published in 2013. Right? If you want to refer his book, yeah, based on your time, you can go and refer this, right? Understood? Yes. These are fundamental definition about the big data. Understood? So see, it's an ability. So big data is an ability to store. I already told you, right? So pushing a data into a storage is not only a thing, how smartly you can handle. For example, if you store the data, so how you're storing a data is matters. Because if you want to retrieve the data, how you can retrieve? Based on your storing only, you can have an idea to retrieve the data. For example, take a library example. So library example, in our colleges, you can see the library. So storing your books in the library, so randomly, who could know? So based on the department, how the library's books have been arranged, have been stored, in other words. So just in a racks, they will classify as the department, or they will classify as a subject, or they classify as like a department in such a way, right? Even in the newspapers, they will classify, or they will store based on a year, a month, day, and so on. This is how smart you store. Understood? In such a way, here data storing is also should follow particular models. Understood? So that's what is it. Big data is the frontier of firms' ability to store, process, and access. That's what I told you. Ability to process and access. Right? This storing, process, and access. These three are called SPA. A simple term is SPA. S for store, P for process, A for access. Understood? So once you, this is a fundamental thing about the big data. See, to accomplish this SPA, there are positions in the companies. There are some positions. So for example, take a cricket match. So while you're watching a cricket match, you can see, for example, if a person is hitting 26s, so suddenly a message will be displayed on the data will be displayed on the screen, like so how many have been hit already, how many batsmen has been hit the same number of sixes, and so on. Even in terms of wickets, any records, like they will display. So what do you mean that? So it means they're retrieving the information in a seconds, matter of microseconds and milliseconds. They're retrieving the information. Understood? So they have some methods to retrieve that query. They will use queries. The technology is different. So I'm taking a high level thing. So technology is different. So they have some particular methods, and they will use in certain approach to retrieve the data. That's what SPA of the big data. Try to understand. So right. So this SPA, why this SPA? So this SPA, it needs to operate. That's what I said. Make decisions, reduce risks. So right, serve customers. Simple term. While we're watching a cricket, we are the customers. So think in that way. So operations, for to make any decisions, this one is already discussed. Understood? So this is what a need of SPA is, this one. There are some needs of the SPA. Okay. So fundamental definition of the big data to understand about big data, right? See, you can see. So this is what simple one more definition about this big data. So he said from Allen's, this is Allen's definition. So one more author. So right, so here I told you, no, this is the term, important term, structured and non-structured. Try to understand this structured and non-structured data I'm talking about. Maybe big. So here he said, right, maybe big or small, structured or unstructured. Yes, it's already discussed. Yeah, this is also discussed. Yeah, it's also covered. Yeah, coming to here, emergency of big data tools. I told you. So this is what a big data. Just now we seen we got some. I hope like you got some idea about the big data. So in real time, how to handle this big data? So there are some tools to handle the big data. So these are the fundamental tools. Here you can see standard SQL. I told you the very important thing of a big data is structured and unstructured. Structured and unstructured, two types of data. These are fundamental two types. There is one more type, semi-structured. Here I didn't put that word, but remember, structured, unstructured, and one more is semi-structured. These are the three types of data. So why I told these three things, because based on the type of data only, we can select a particular tool to store, to handle, or to perform SPA, as well as to handle this data or to process the data. Understood? Structured data, unstructured. Is anybody having this difference between these three? Anybody have the idea about these things?
Yes.
Yeah, please.
Structured data means like having a like foreign key. There are in SQL there is a foreign key and primary keys are
SQL,
present.
yeah, good. So SQL, this standard SQL is a tool to
Structured
handle
query
the
language.
structured data. Yes. SQL is a tool to handle the structured data. Yes, I agree. So SQL is a tool to handle the structured data. Yes, I agree. But what is structured data? For example, yeah, please, anybody?
It's a properly managed data is called structured data. Like everything is managed.
Managed.
No cells are empty. Like in Excel, there are no empty cells or no missing data. It's called structured data.
Yeah, sure.
Maybe
See,
something is missing, then it is called unstructured data.
Okay. So simple thing, yeah.
And there is no relation. Okay.
It's a simple, yeah, sure. What you said is exactly right. Some basic definition also. I would like to add some more things to you. So thing is, structure nothing but a kind of tabular format. Simple thing. Structure nothing but type of tabular format. Is having some rows and having some columns as well. Rows and column structure. RC structure, simply they're called RC structure. Rows and column structure is called a SQL. So everywhere, even the very fundamental stuff you might be observed. So as he said, as your friend said, SQL, he mentioned a word called SQL. So many of you might be knowing the SQL. So simple, I am giving you one simple thing. Select, right? What is the, sorry, pen is not working well. So SQL, the very fundamental statement of SQL. What is the query of the SQL? The basic query of the SQL is select a table, right? Or create a table. You understood? Select a table, create a table. Anybody respond? Anybody please respond? Have you seen these queries? Yes. So in the name itself, table. Try to understand the table word. So table, why it is called table? Because table is having a row column structure. So if any data is given to you with a row column structure, then it's called as a structured data. So missing values would be there, but rate is very less. Maybe having missing, for example, go to Aadhaar card data. For a government, you can think about the Aadhaar card data. So sorry, not Aadhaar card, person's data. He may having Aadhaar card. So the person is having the person name here, one Aadhaar card, right? PAN card, like voter card, driving license, and so it's a right. So Aadhaar card number, right? PAN card number, voter card number. He may not having a driving license, right? So you can miss the data. So is this data is required or not? That's my question. Yes. So I am giving you veracity. I am giving the exact meaning of veracity here. Try to understand the correct meaning and real-time meaning of the veracity. So in real-time scenario, what you say, what I said, veracity. So if any inconsistency in the data, right, you can found the kind of thing we call as a big data. But even if some data is missing, it is not like a big issue. Even with some missing data, you can able to predict the data. Even with some missing data, you can handle the data. If the missing data rate is very less, you can manage that missing data. Understood? No. So even it may not be a important data. It may not be a primary data. You understood? Those kind of things, right? So that's what I like. Try to understand this in real-time scenario. So this kind of data is in the table format. Then it is considered as a structured data. Understood? So coming to unstructured data on the other hand, so I told you SQL is used to handle the structured data. NoSQL is used to handle the unstructured data or semi-structured data, both. Understood? Example for unstructured data is media files, audio files, understood, and so on. It's a kind of mixture data, unstructured data, right? So in order to handle these kinds of data, we are having a very fundamental tools is NoSQL as well as a SQL. Understood? Not only this based on the data, there is one tool I told you, Hadoop. These are the most important tool to handle and to process the big data, Hadoop technology. So this is a very important course nowadays. If anybody wants to learn, yes, can absolutely learn this Hadoop technology. And Hadoop is a very fund and a heart and soul of the big data. Hadoop technologies. Understood? So I told you, like in olden days, this is the difference between this. To store the structured data, yes, we have a memory, and like but in like similarly for a semi-structured polystructure, there is a streaming. So you can observe what is a streaming here. So in the streaming, you can see some kind of series process as well as a parallel process. Here you can see from here to this is the input node and this is an output node. You can see here stores, this is a store, this is operator. You can see from here there are two parallel paths, understood, from node to node, as well as here also again it is again parallel piped. Here also again parallel, here also series. Again there is here this is series, here also series. Before parallel there was a series. This is after parallel again series. So a mixture of series and parallel processing. So what we're doing here, these are kind of streaming the data in such a way it is easy to handle. Not we are handling at a number of volumes at time, at a single time, right? Just we are going up parallel processing or series parallel processing. So try to understand, right? So yeah. So here I told you, Hadoop. This is a Hadoop technology. Here you can see these are some kind of applications. So here you can see the unstructured data, right? So here you can see three sectors. Let me see three sectors before going to in-depth discussion. Let me have a high-level explanation. So this is what analytics, data systems, and the sources. We know data starts at sources. These are three stages of data. Overall, what we're doing in the real time. See, even you can find your own job in terms of real-time scenario, or if you want to locate yourself anywhere. So big data is not a single portion, right? It's a complex, it's a complex architecture. It's having different resources. It is having different things, having different tools. It is having different designations. It involves different positions. You understood? Try to understand here. So you can locate yourself anywhere in the 3 stages. First one is at the sources. Second one is at the process data systems. Third one is at analysis, analytics. So when you collect the information at the sources, these are the different sources. So if you want to like know any here unstructured data, what you do at the sources. So being in a service sector, so how could you handle this thing at the sources? So what you should learn at the sources. So these are some things, right? RDBMS, you might be knowing this RDBMS, right? CRM, ERP, clickstream, web and social, geolocation, sensor and machine, server logs. So structured, unstructured. So these are the positions at the resources. So coming to data systems, see here you can see data warehouse, right? So this is what a data warehouse. This is a data warehouse. This Hadoop technology I told you, right? Streaming, processing. So this entirely at this position, it is only data process first after the sources. Last one is like a analytics. Here you have some charts and you will display the data in terms of charts as well as dashboards for visualization purpose, as well as like kind of pie charts, graphs, many analytics you can see. Not only a visualization, but also matrix mathematically you can visualize the data. In a structured way also you can visualize the data. So here, whatever the data you want exactly, the data is prepared and processed. Simple. Whatever the data you were expecting from the historical data or huge data, that will be simply presented and it retrieves, portrays the data. This is what analytics. So there are some tools. Anybody knows the tool about analytics? Have anybody heard the tools analytics? Can anybody name some analytic tools? It's very
Yes,
famous tools.
Tableau.
Yes. Tableau, very good. Power BI, exactly. Tableau and Power BI. These are some analytic tools. So try to locate. So my intention about this thing is like, so try to locate yourself at any one stage. So at sources or a process or analytics. So these are the different stages of handling or to work with the big data. Yes. So this is what are some more the same slide, just I'm exploring with the companies as well, the famous companies behind these things. So here you can see, so Hadoop, this is a Hortonworks. You can go and browse about these companies. So it's right. So Hortonworks, you can go and know some information about this Hortonworks. Similarly, SAP, HANA, Teradata, Oracle, MS SQL. See, Microsoft SQL Server. This is MS SQL. Somebody says like server, SQL Server. It is from Microsoft. So these are different companies behind the process. So see, they like proposed some systems, some tools to involve their tools at particular level. Stood here, web and social, geolocation, sensor machines. So they're at a sources. Then this Horton network and Hortonworks, as well as Vertica, Teradata. So these are like some at process. So they have some tools, right? So that's what like here you can see some operation tools, Teradata. So here you can see the Teradata. So they developed some tools. Even OpenStack is there, Red Hat Technologies, Cisco, HP, NetApp. So right. So these are some companies behind under big data. They're continuously working on big data. They're continuously like developing a new tools and solving the tools and like brushing up the tools about the big data. So yes, one of your friend like told at the application side, Tableau. Tableau is famous. Power BI is not. I didn't mention here, but Power BI is also tool. So like Tableau is a tool, SAP, SAS, MicroStrategy, Splunk, Revolution Analytics, Platforma, HP, Excel. Excel is also right. We can say Excel is also like a tool, visualization tool. So because everybody knows about Excel, but why Excel is used? The main purpose of is visualization. Simple thing. So you can know the purpose of each company and each tool and the company behind the tool. Understood? So these are, if you want to take,
Cannot process big data in Excel, right?
yes, you cannot process, but it's a tool for visualization, right? Yes, exactly. You understood? So these are some companies behind these tools. Yeah. So if you want me ask, so I told you, so my concentration is most probably, yeah, I want to bring you one point here. This streaming is a very like a complex thing under the big data. So yeah, application wide are for visualization tools, working with visualization tool, working with the sources, working with the visualization tools, and working with the sources is one thing. The very challenging thing under the big data is working with the processes, working with the processing, streaming. So very somewhat complex compared to visualization tools on the sources side. So you can think about yourself, and like even the packages, you see, and the packages uh, is high at a streaming side, processing side, tools with the processing side, than the tools with the application side, than the tools with the source side. So even the requirements as well, most of the requirements may be under the streaming side only compared to source side and mining side, as well as application, I mean visualization tool side. So many people will try to learn these streaming applications than this. Yeah, there are people who learn these packages, these visualization packages. Nowadays, these also getting increases. But yeah, combination is also, there are people who learn combination packages as well. There are people who learn these combination packages as well. It's up to you and your capacity, like how you're dealing the systems, and how like deeply we're learning the technologies, then is the matters. So to enter into the big data technologies, but there are like specific roles which really have a demand on the big data side, so with the streaming applications. So try to get the difference and try to understand here itself only. So kind of what kind of technology you want to learn and where you want to locate yourself under the big data applications, even in big data architecture. Yes. So yeah, I worked on this side, streaming side, even I worked on the sources side. I didn't get a chance to work on this visualization side till now. Yeah, maybe I don't know whether I would work or not, but yeah, I didn't get any chance to work on this visualization side. Yes. So coming to yeah, but a thing is, in a like real time. So these people will coordinate with these people, and also will just coordinate with these people. So we should have some knowledge about this. So it didn't work in the sense not knowing anything. It's not like a zero thing, but yeah, we know something. But on top of the application wide, like on top of in real time, so how could we deal the system is a thing, main thing. So that kind of knowledge really, when it works, and when we have a like of most familiarity with the uh, data and real-time tools, then only we could get to know the real content about the tools, right? But everybody has the knowledge on this, so try to understand that. And so as I said, streaming side, this is what a big data architecture. So I told you there are different things. So very important thing, not only a this is not only a Hadoop, you can say it's a Hadoop technology only, but Hadoop itself has a different tools. Try to understand this. So I'm talking only under the streaming side, processing side, only under the processing side, streaming side. So there are different technologies, not only a single one. You can say on this visualization side or the sources side, there are different technologies. So you might be not seeing here streaming side, but yeah, I'll take you that application as well. Yeah, these are the different technologies. These are tools. In the big data architecture, you can find different tools. Scoop is a tool. Hive is a tool. MapReduce is a tool. Pig is a tool. Pig, the funniest thing of the pig. Pig is a tool. Why it is called a pig? It is why it is named as pig. A simple example I'll give. Why it is called as a pig? Nothing but pig eats everything, every kind of food. In the same way, this pig tool deals with every kind of data. It can be structured, unstructured, whatever may be the data. It's a pig. Hive, Scoop is there. MapReduce's job, MR jobs, Zookeeper. Understood? So these are the technologies under the Hadoop, but the base structure is like a HDFS. This is a structure. Distribution file, Hadoop distribution file system. So based on this HDFS, so here it depends upon the requirement only. So if you'll think in an architecture way, it depends upon the requirement. So the person who knows Hive, the person who knows Pig, the person who knows Scoop. So sometimes it doesn't need to use a Scoop. Sometimes it needs Pig. Sometimes it needs Hive. Depends upon only requirement. So based on the requirement, so yes, we like to know particular tool, but it is not mandatory like to know about all the tools. Knowing the tools is very important on this requirement. So in one company, one of my friend working in X company. So there is handling only Zookeeper job. Only is performing Zookeeper. It's a very big company. The data is used and the requirement is used. So it's simple opportunity matters. But simply when we're learning about a particular technology, so this Scoop and Pig technology is very, very small. To learn this Pig and Scoop is it will take very less time. But there are technologies where they will use most of the times, or less times, or rare occasions, or where they actually needs. It's kind of a requirement. That's what I said. Based on the requirement only, we'll use a particular tool and technology. It does not mean we should use all the technology at once. No. But the base structure is HDFS. We should know how the HDF is this file system works. How this file system works. This is what a base thing, right? So when we're learning into this HDFS, so try to understand the file system very perfectly, so that on top of this HDFS, everything is on top of this HDFS. On top of this HDFS, how many tools you know? That is the question. How accurately you know the number of tools? There the matters. There you differs. There you differs actually. So these are some tools under the architecture of big data. Right? So I told you. So data lake. Does anybody have idea about the data lake?
Yes.
Yeah, please.
From where we get the data extracted and transferred and loaded to the warehouse.
Okay. What is the difference between data lake and data warehouse? Are they same?
In data lake, it's unstructured data.
Hmm.
In data warehouse, we categorize and structure the data into pieces and parts.
Yeah, fine. See, simple. Yes, exactly. So data, yes, data, as you said, data warehouse is structured, and what is ETL?
Yes, extract, transfer, and load.
That's what you said. Whenever you use a data warehouse, you must tell about a ETL, right? So simple data warehouse, it's a structured and this data will be curated. That is like a ETL, extracted, transformed, and loaded from various sources. Understood? It's a data warehouse. It is having some repository. Data warehouse is a kind of repository of structured. Understood? Like you can curate the data by from various sources. Curate nothing but ETL. Yes. Similarly, data lake. Can anybody give the data lake? Data lake is a distributed repository. I told you data warehouse. If anybody have this knowledge, you can understand more about this. Simple, very big difference is data warehouse is a centralized repository, but data lake is a distributed repository. You understood, right? So, and data lake is a unstructured data, and like some data ingestion is happening from various sources. So try to understand between data lake and data warehouse. Earlier, previous old one is data warehouse. Nowadays, we're using data lakes. Understood? So that's what our main difference between a data warehouse and data lake. And see, yeah, this is an architecture. You can see the previous architecture is this one is architecture. See, you can see the data architecture of the data lake. So this Hadoop stands here. Try to understand. Apache Hadoop stands here. Hive is here. HBase is here. These are all technologies about big tool, right? Already I told you, right? We have seen one slide. So there you can understand SQL, NoSQL, new SQL. SQL is to handle the structured data. NoSQL is to handle the unstructured and semi-structured data. Understood? So here you can see the sources, right? Audio, video, images, docs, text, XML, web logs, clicks, social graph feeds, sensors, data from sensors, RFIDs. You understood? So these are the huge sources of data. So these data will be sent to this processed through this Hadoop. Unlike next, we'll go to this analytics purpose, business purpose, and application purposes. So there you can see different tools involved in the analytics as well. Not only that, the sum of we have seen now only, but this is a data architecture through data lake, not data warehouse, data lake. Yeah. So these are the companies. Yeah, these things we already discussed. These are some companies. Understood? Yeah. What you consume from Delta Lake. So why I'm coming to this picture is because, so I told you here we have seen some stages about the big data, some architecture about the big data. We learned some tools about the big data, and continuously when we coming to this one, the very source of that big data is data lake, right? So that's what I want to introduce, this data lake. If you don't discuss this data lake, then big data is incomplete. So I want to bring up the discussion of data lake here. Understood? So yes, you can know about the data lake. So the demand of the data lake simply just increasing. Yeah, there are some features about the data lake and there are some challenges. So even you can see in the data lake, yes, compared to data warehouse, yeah, there are more big challenges on the data lake as well. So you can see here network maintenance. In the data lake, network maintenance, I know the meaning of network maintenance, no need to elaborate more about this. The network maintenance of this data lake, for example, simple, if you want to know about the network maintenance, simple, you can visit any server rooms of your colleges, or like server rooms, any companies, any server room, even telephone exchange server rooms, any small companies server rooms, the network, how they will maintain, and not real time, I'm telling you, how they will maintain, what is the structure of that network, So how like in a network, how each processor or each architecture or each repository is switched on, switch off, which one is switched on, which one is switched off, right? There is a tool called, yeah, I am telling you one application here. Just I am giving you one tool here. If you want to know, if you so if anybody is interested in the network side, right? If anybody is interested in storing side, so you can learn this tool, Grafana, graphite or Grafana, both are same. Grafana, Grapana, Grafana. It's a tool which is used to give most of the information about the network. For example, in the network, there are different systems are running parallelly. In the network, and more number of systems are running more continuously and long time, from a very long time. There you can know that analytics, temperature, processing time, and how they're performing, how the accurate they are, how much accurate they are. There are different, there are n number of features we should monitor for a network, n number of features. This a Grafana is a tool. Grafana is a tool which can give all the monitoring features about the network, all the n number of features about the network. It's a tool called Grafana. If you have a time, open the browse about the Grafana more and more. If you are interested with the source side, and nowadays, so this Grafana tool, it's a very old tool, but now they are like developed more properties on more features have been added to the Grafana tool, because so this issue data lake. Now to address the data lake, so the very first thing is network thing. So you can learn about the Grafana tool, so that yeah, there are some positions on this Grafana tool.
Sir,
Yes.
Grafana tool used for telecommunications.
Yes, that can be also used for telecommunications. So what is a fundamental? Yeah, tell me.
Kalyan sir,
Yes.
before going much deeper into the subject, so
Okay.
most of the students, most of the people in this current session are students. Okay, so can you elaborate little brief on the career opportunities side? That is one thing. I have one question from my side. Like, does the data science, artificial intelligence, and machine learning, is it anywhere related to big data also?
Are you student?
No, but I am not from this background. I
Sorry?
don't have much of a clarity on this, but I understood what you're talking about.
Okay.
But on behalf of students, I am just asking.
Okay. So what do you want? Please tell me.
No, one is I understand you are also a data expert into machine learning and deep learning. So this big data is the one which we are talking now. So
Yes.
is it machine learning and artificial intelligence, the concepts also being implemented in this big data, or is it completely two different domains?
Yes, good question. Yeah, I want one slide to understand these things, right?
I think big data is used to
Yes, understood.
get a models of ML data.
Yes. So why? So because all these are students only, like I'm giving them like, see what I'm trying to explain is that, so I'm giving them good tools, real-time tools to understand at various locations or positions. You understood? So tools and the company's names and the structure of the company, yeah, there are like more opportunities with what tool they'll get opportunities with what tool they can use at which location. You understood, right? Am I audible?
Yes.
Yeah. In that sense only, like I'm going in way. Okay, sure. If you want that again, yeah. If anybody understood, like they can use these resources as well. Okay. Yes. See, here application, right? So this is application. Say here you can see the machine analytics, right? So what we do with the big data? So data is collecting from the sources. Try to understand. Data is collecting from the sources, and from data collected with some tools. There are many tools. Just now we discussed. We will process the data. And we will shape the data. You understood? We will shape the data and we'll process some analytics. I just now your friend is asked on behalf of you. This is called term analytics. What is this analytics? What you do the analytics?
Visualizations.
Yeah, no, visualization is one thing. From visual, what is visualization? Just like some visuality of the data, right? Some visuality of the data. After that, I told you in the first definition itself, these are helpful. These are helpful. Why are you doing all this process? These are helpful in order to make some decisions, right? Business decisions which are related to businesses or which are related to the customers. You understood? You need to go from predictions, or in other words, predictions. We'll also call some predictions.
Hypothesis.
Yeah. So this how you would take some decisions by this data. This
Based
output
on
data.
data.
Yes.
Analyzing the data. Like,
How could you take the predictions? How could you take the decisions? How could you know about the data? You understood? No. So these there the exact role of machine learning will comes. Machine learning. So we will use this data. What is the processed data? We will use the processed data, and the processed data is again melded with some methods. These are machine learning methods. These are machine learnings are basically some algorithms. They are the set of algorithms. So these are the set of algorithms. So on top of this processed data, we will apply some algorithms. We will supply some algorithms, and we will again meld this data. We shape this data. So there is term is called data cleaning. This is called data cleaning. We will clean this data. Understood? So yeah, data cleaning is there. So we will use this entire data in order to apply particular algorithms or particular machine learning methods. So based on these methods, we'll take some predictions. So for example, if you want to predict a particular proposal for a particular business on this data, on the top of this data, so there exactly how much confident you are to take the particular decision. That is what an accuracy. So this accuracy will be modeled by using some algorithms. Will be tested by using some algorithms. This accuracy of prediction, this accuracy of making some statements, this accuracy of making some decisions. Understood? So there the real application of ML tool or AI tool will come placed. So that's what a complete application will be built by using this big data with the help of ML.
Got
So,
it.
yeah, yeah. So on top, so there is a chain, right?
Understood, sir. In analytics part, this data science, I mean, especially artificial intelligence and machine learning will come. Ultimately, it will build a complete application into it.
Yes.
Sir, Kalyan sir, one more thing, like
Yes,
as
sir.
if I have seen some of the videos quite 6 months before, this
Okay.
data related job roles are especially only will come to a boom after 3-4 years.
No,
That is
no,
one.
no. No,
Yeah.
actually, yes. So under real time scenario, yes, it is quite requirement. So why after 3-4 years? Why? See, because the reason is simple. AI. It is not a ML. It's a AI. Nowadays, ML is okay, but future AI must be there. So yeah, AI is the mother of deep learning and machine learning. You know that?
Yes.
Yes. So simple. I'll tell you. Artificial intelligence. 3 words. These are the 3 important things. AI, machine learning, deep learning. If you understand these 3 things, then simple. You can understand your question. So machine learning and deep learning, both are types of AI. Both are the subsets of AI. You know that, right?
yes.
Yes. So both are subsets of AI. So what you said, sir, just you asked like machine learning and deep learning. Nowadays, the roles for machine learning are good. Yeah, they are fine. The loads of the roles for deep learning, roles in the sense opportunities. Opportunities for deep learning and machine learning are good, no problem, but not AI. The applications point of view, AI roles point of view on AI are very, very less nowadays. So what the people think, like in above future 3-4 years later, like AI will trying to dominate the things. So when AI is like is started to use in every companies and in every most of the applications, when they started to implement this AI, they really like no one consider this ML and DL. You understood? Because roles are related to subsets. Nowadays roles are related to ML, because most of the banks, most of the businesses, most of the like corporates, most of the medical applications, they're using ML and DL as well as DL also. But AI is not yet being used in practically in real time applications. You got my point, sir?
Yes, yes.
Yeah, so because of that, yes, whatever they're telling in the future is right, because if if the AI technology is start to use in a real time applications, obviously the demand for machine learning and deep learning will get reduced.
So what do you suggest, sir, for students, especially
For
an year?
students, yes, the basic thing is they should know about the architecture side. So
Okay.
when we know the architecture, data architecture, that is not a AI, it is not a ML, it is not a DL, it is not a data science, it is not a big data even. So they should know about the big data architecture, entire architecture. So that's why I shared you a pic called architecture. So when you go this architecture, at our locations, so what is your roles? So when you know every role, not only textbook knowledge, so in real time, so at which location, so they want to commit, at which location they are interested first of all. Otherwise, not only interest, sometimes we need to lose our interest because of the roles, because of the opportunities. So first of all, we should know about the number of opportunities, at which side the opportunities are more. As the time is varying, the locations, opportunity of the locations also varies. So my suggestion is like we should be very clear cut in learning a technology. Before you learning a technology itself only, you should know about the opportunities of the particular tool.
Sir, how does the student can get to know all these things? Like,
Yes,
which technology is going to vary in the next 2 to 3 years?
it's a
What I-
market. Yeah, it's a market, and it is from the friends or either from the relatives. And so that's what I'm telling you. So latest market is important. Latest technology.
So now if somebody
Now,
learns.
yeah, I will
at
tell
a-
you. Yeah, because if the final year student is there now, so yes, now you can go to the big data technologies now. So from big data ML, so three roles, right? To understand, analyst, data analyst. Sorry, pen is not working. Yes, data analyst, data scientist, data engineer. These are the three roles. Data analyst, I told you, no, analytics side, data scientist, machine learning side, data engineering, streaming side. Understood? It is related to big data. It is related to big data. It is related to machine learning. It is related to big data. Data science portion, scientist portion is related to machine learning side. Data analyst is also related to big data, but between the big data and machine learning. Understood? Data analyst is between the big data and the machine learning. So what I'm suggesting is that in all the three sectors now, from now to coming 5 years, as I said, coming 5 years only, the machine learning is for machine learning and big data has a future, no doubt about that. So any tool in the big data on the machine learning, so you can learn any tool under the big data, or you can have a knowledge on machine learning as well. You can practice them as well. Within 2 to 3 years, if you can place yourself in any big data side or machine learning side, so what happens within 2 years, 1 or 2 years, then what happens in coming 5 years, at the end of 5 years, 2028, somewhat kind of before 2030 only. So what we'll get, we'll learn some experience under the ML side and the big data side, real-time experience. So there again, obviously, even you in the market, it is not like the real scenario is, even you are a job holder, even you are the IT engineer, So it is not like you are ends up with the technology. You must advance the technology. You must be advanced in every technology. You understood?
Yes.
If any new tool come, so think in real time. If any new tool if any new technology is coming into the market, you must learn this, because enhancement is always right. The enhancement is always. So obviously, if you know this machine learning or big data, so after 5 years, so you will work for 3 years in the IT company. So after 5 years, so obviously we must there you can able to take your decision. So in which study how to move, unlike should you learn any new tool, or should you learn any technology, or you can fix in this present tool only with your experience, carrying experience like a potential energy. Understood, right? You can be rolled up after 5 years. You can be rolled up with your same experience as well. It's about the getting an opportunities. That's what I'm planning about your career. But the fact is this one. You understood?
Yes, sir.
Yes. So yeah, this is what our future plan on a future market as per as my scenario. Yeah, even I'm looking for many MNCs nowadays. This is what a
So
big scenario.
one more thing, so this, I mean, when we are talking about big data, does it like only big players use this technology like IBM?
No. It's not like, it's a very myth. So thing is, yeah, very good question. So thing is tools are required, right? Anywhere you can use the tools. So even startups. Yeah, one more thing I want to stress you. I missed it. That is, actually I'm trying in a flow. So no problem. Somewhere I missed one thing. I didn't come to the flow. Okay, no problem. Time is running out. So cloud, right? I told you cloud. In the source side, I told you network maintenance, Grafana tool. So later I would come to this point. Yeah, this is one technology. This is nowadays cloud technology. You know, right? It's a very popular area nowadays.
AWS.
Cloud. There are 3 courses on this cloud. One is
AWS.
GCP, yes, from Google, AWS from Amazon. Next, Azure, Microsoft Azure from Microsoft. These are the cloud technologies. Yes, he may be a machine learning engineer. He may be a big data engineer. They should learn this cloud technology. Without this cloud technology, it's very difficult to survive in the IT sector under the data side. It's a very straight statement nowadays. Yes, there are some people who are surviving without these technologies, but in future it should be difficult. It would be difficult to survive without these technologies. It's a cloud. So try to understand this statement. So how much time do I have, sir?
10 minutes, sir.
Yeah, thank you. See, as per the cloud is considered, so they provide many resources. Try to understand this. It may be GCP or AWS or Azure. It may be of Azure. Understood? So they will provide many resources, whatever the things we have discussed now. For them also, the cloud provides many resources. They have the ready-made culture, ready-made applications. They have particular applications. So if you learn these technologies, yeah, the demand is hiring. Even for 5 years of or 3 to 5 years of experience with the cloud and AWS and Azure, the package is going to 20 lakhs nowadays. 20 lakhs, no doubt about that. Minimum package is 12 to 15 lakhs for a cloud engineer. I mentioned you three things, right? Data engineer, data scientist, data analyst. So cloud is different sector. So yeah, even you can so yeah, I will tell you some bridge between this cloud technology and the cloud engineer and the data engineer. So cloud engineer is also called data engineer. So whoever learns, try to understand here, whoever wants to learn this GCP, AWS, Azure, it is not a single chip. It is not like a single subject. It is not a single technology. This cloud contains entire structure, the entire data structure, entire data architecture. You got my point? So see, when you choosing, you may ask, so which one is better in these three? You may ask like the GCP, AWS, Azure. All are same. Three are same, the same level. Their resources and the providing and the rates and the tariffs are different, but technology wise, all three are same. Okay. So here, what I'm trying to explain you is that, so if you, for example, if you learn GCP, yes, knowing a GCP also, by knowing a GCP, through GCP also you can perform big data job, big data engineer job. You understood? So there are some tools under the GCP as well. There are some tools under the AWS as well. There are some tools under the Azure as well. Okay. So yes, so these are the also rising demand nowadays about this cloud side also. Okay. Yeah, any further more information, because of time, like I'm trying to cover a number of things. Yes. Any queries you can ask, like so I want to give you some bullets here. So yes, once you know the bullets, and like based on the opportunity wise, like also you can have some more explosion on this big data technology. Yes, thank you. So any doubts, like I'm really happy to answer you and help you.
I think Kalyan sir, it's a wonderful session because what I understood, I can summarize something like we have spoken different technologies, like cloud is a technology. Again, in cloud, we have multiple companies and multiple variances. And we have data science, data analytics, data engineer. This is a kind of a thing in which, again, like AI, ML, deep learning. When we talk about big data, we have Hadoop and data initial source and data analytics. So I think as an engineer, especially in the current era, like everybody has the access to the information, then we should know about every technology, at least what is what.
No. Yeah, sure. Good. When it's here, I want to stress one thing. See, knowing what is okay. See, when you know the, like in YouTube, or like when you learn any online courses, yes, you can learn some online courses. You can go through the YouTube and to get what is what. Yeah, what you said is correct. So what is okay, but when you want to work in the real time scenario, so what is not enough. So when we learning, am I audible, sir?
Yes, yes.
So the very important thing to the students is that, so when you, so many, even we as a before 10 years, like we learned the things, but in a real time scenario, knowing what is what will not works to survive in the real time. So we need to learn the course in application oriented way with the real time examples. So really, I want to address the students with the thing, when you're learning. So even nowadays, information is anywhere, every place. So just browsing a thing, you'll get the meaning of the word, meaning of the word, meaning of the technology, and like handling the tools and snippets of the tools as well. But when it works to the real time, how to adopt the learn the technology, how, whatever the technology you have learned, whatever the tool you have learned, so how you are adapting, how you are molding the tool or technology for the real time application, for to work in the real time, so to adapt to the applications. So everyone should learn in that way. So any course or anywhere or any information, if you don't learn into the application, then it is like just a knowledge. Okay, thank you, sir. Please continue, sir.
Yeah. Thanks, sir. Anybody have questions?
Oh, no, sir.
Okay, thank you.
Still, anyone have any queries, or shall we wind up the session?
Is Skilldesign is providing a big data course?
Gopi Krishna ji, basically, no,